Today's lesson is going to be on combining like terms. You're going to need your toolkit for this. And if you just take a look at the screen, all of the terms that are in the same color would be the same terms. So if you look at the 3 in blue, the 4 in blue, the -7 in blue, and the -6 in blue, those are the terms that you would be able to combine. So I could not combine this 4 with the 2x that's below it. So I'll talk about this a little bit more in the video. Alright, so you're going to need this toolkit entry on combining like terms found in Chapter 4. We're going to take a look at it together. We're going to highlight or underline some important things, and we're also going to take some notes. Let's begin by reading. This course uses tiles to represent variables and single numbers called constant terms. So the constant term, I'm looking at the expression right here. The constant term is just the number. So that's just the number 2 in the expression. The constant in this expression is 2. Combining tiles that have the same area to write similar expressions is called combining like terms. So when we combine terms that are the exact same, that's called combining like terms. More formally, like terms are 2 or more terms that have the same variables with corresponding variables raised to the same power. So we're going to take a look at this in a little bit. So let's look at the examples. We have examples of like terms, and the examples are 2x squared and -5x squared. They are like terms because they have the same exponent on the same variable. So then the second example they give you is 4ab and 3ab. They are like terms because they have exactly the same variables in them, a and b, and the a and the b are to the same power of 1. Non-like terms in the next example, so non-like terms are 5 and 3x. Those are not like terms. And then the other pair of non-like terms would be 5x and 7x squared because the x with the 5 doesn't have the same power as the x squared with the 7. So I'm also going to point out that there are some examples in this toolkit entry that you can take a look at, but we're going to take a look at our own. Alright, so this is the first example we're going to take a look at, and when you get an example like this, it's going to say simplify the expression using combining like terms. So we need to identify the like terms in the expression. So 4x has a number and an x that has no power. The x has a power of 1 actually. So we need to find another term that's exactly the same. So the other term would be the 2x. So I'm going to rewrite these. 4x and 2x. I'm going to put them together. Then I'm going to move on to the 6x squared, and I'm going to find the term that's exactly the same as that one. That's 8x squared. So I'm going to write those together. They are exactly the same because they have the same power on the same variable. And the last one, 10 and 9 are just constants in the expression. So now what I'm going to do is I'm going to add these. Okay, so now we're ready to add them. We have 4x and 2x, so 4 plus 2 gives me 6, and I keep the same variable. Notice in the original expression there were all addition signs, and there were no negative values. So all of my answers are going to be positive, and all of the terms in my final expression are going to be added together. So then I have 6 plus 8, that gives me 14. The variable with those is x squared. That means I have 14 x squareds. And then the last one is 10 plus 9, that gives me 19. So let's try another example that's like this one, that has all positive values and you're adding them all. And then we're going to take a look at some harder ones. All right, why don't you take a look at this expression and see if you can find the terms that are alike and group them like I did in the last problem. So hit pause, copy the problem down, and see if you can do it on your own. Okay, so the ones that are alike are in the same color. The 3x squared and the 6x squared, they are like terms. The 4x and the 2x, and the 1 and the 4. And again, everything has addition signs with it and no numbers were negative, so we're just going to add them. When I add 3 and 6, I get 9x squared plus 4 plus 2 gives me 6x plus 4 and 1 gives me 5. So my end result, or my answer, would be 9x squared plus 6x plus 5. That's all the further I can simplify it. Let's try harder examples. All right, so this example is a little bit harder, and you want to take note that there are negative signs or minus signs, which means you're going to be subtracting that value. So I'm going to be subtracting this 4x squared from this 6x squared. Okay, so that's important to note. So let's take a look at the example together. I'm going to combine the 3x and the 6x, and then like I said, I have a negative 4x squared, because that means I'm going to subtract it, and then I have a positive 6x squared, and then notice I only have one constant term, and that has a minus sign in front, which means it's a negative 10. So now we have to put these together. All right, putting this together, 3 plus 6 is 9x. And then we have negative 4 and positive 6, so that's going to give us positive 2x squared. And the negative 10 doesn't have anything to combine with, so I just have negative 10. So my final answer is 9x plus 2x squared minus 10. So here's the next example. I want you to copy it down, pause the video, and try to find the like terms on your own, and then check back to see if you got the right solution. Okay, copy it down and pause it. All right, so I copied them down and I brought the like terms out of the long expression and put them together. I also included the sign that was in front of the number. So 4x plus 2x gives me 6x. 6x squared minus 8x squared, or you could say 6x squared plus negative 8x, is still going to give me a negative 2x squared. And then last one, 10 plus negative 9 is going to give me positive 1. So my final answer is 6x minus 2x squared plus 1. So if you think you understand how to do these problems, don't worry about these 3 examples. But if you think you need more practice, copy these 3 examples down, hit pause, and then go to the next slide to see the answers or the solutions worked out. All right, so I'm going to work out that first example. All right, so let's take a look at it. We have a 1, and our other number is negative 10. So 1 minus 10, or 1 plus negative 10, is going to give me negative 9. Then we have 8x squared and a positive 5x squared. That's going to give me 13x squared, and that's positive, so I put a positive sign in front of it. And the last one is x. I made a mistake, so I need to go back. But x is by itself. I'm not adding it with anything, but I see something else I forgot. I have a plus 6, so I need to go back to the first one and add 6 to 9. So that gives me negative 3 plus 13x squared plus x. All right, here's example 2, and I'm going to work through it kind of fast. So 2x and then negative 6x gives me negative 4, negative 4x squared, and positive 2x gives me negative 2x squared. And then I have a plus 2 behind it. That's my final solution. All right, here's the last example. And I have a 6x squared and a 2x squared put together. That gives me 8x squared. I have a negative 2x and a positive 4x, so that gives me positive 2x. And then the last one is 6 minus 1, which gives me positive 5. My final solution is 8x squared plus 2x plus 5. That's it for the video today. I hope you understand how to combine like terms. Please continue on your outline.